Alrighty, let's do it. Your second video of week 2. We are on 11.4, which is other angle relationships in circles. So, right off the bat, we're going to start with theorem 10.11, which tells you that if a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. Okay, so measure of angle 1, its intercepted arc is this right here, so it's 1/2 the measure of arc AB. By that same logic, angle 2 right here is 1/2 the measure of arc ACB. So measure of arc ACB. Okay, so pretty similar to what we talked about in the previous section. Okay, example 1 here, it says line M is tangent to the circle, find the indicated measure. So if I'm looking for the measure of angle 1 right here, its intercepted arc is arc BA, so all I have to do is take 1/2 of 132, which is equal to, what, 66 degrees. Okay, if I want to find the measure of arc EFD, so from E to F to D, notice that that's the intercepted arc of this angle right here, so just double it. 2 times 110 gives me 220 degrees. Okay, so not too bad. Continuing on here, our next theorem talks about angles inside of the circle. So if we take a look at this, it says if two chords intersect inside a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. Okay, so that was a whole bunch of talking. Let's kind of mark this diagram up and take a look here. So it says measure of angle 1 right here is equal to 1/2 times the measure of arc DC, that is its intercepted arc, plus the measure of the vertical angle to it, this one right here, plus the measure of arc AB. Okay, so we'll switch up colors here to show you the next one. So measure of angle 2. So I'm looking at this angle right here. This is its intercepted arc, so I could say measure of arc BC plus the one that is intercepted by its vertical angle right there, plus the measure of, so that would be what, arc AD. Okay, so another one here talks about, so I want to backtrack here a second. That is for when they are on the inside of the circle. Okay, then right off the bat we're going to talk about what happens if it's on the outside. Okay, so theorem 10.13 says if a tangent and a secant, or two tangents, or two secants intersect outside a circle, so they intersect like right here, here, and here, then the measure of the angle formed is 1/2. Now this is the difference of the measures of the intercepted arcs. So when we were on the inside, we were adding. Outside, we're now going to subtract. Okay, so just to kind of highlight what's going on here, this one's saying the measure of angle 1 is equal to 1/2 times, notice the parentheses there, it's the quantity of arc BC minus, let's switch it up here, minus arc AC. Okay, exact same thing in the other two. Okay, so we're just subtracting there. All right, so let's do a couple of examples here. This one is asking us to find the value of x. So x is this angle right here. Notice that they are intersecting on the inside of the circle. So I would just take 1/2 times 140 plus 112, which is 1/2 times, what does that give you, 252, which is equal to 126 degrees. So that's my angle. They were intersecting on the inside, so yeah. Okay, example 3, now we're talking about on the outside of the circle here. So remember, outside meant we had to subtract, so I'm going to go x is going to be equal to 1/2 times, now I'm subtracting, 170 minus 72. X is equal to 1/2 times 170 minus 72 is 98. So I'm going to get x is equal to 49 degrees. Okay, and this one is kind of a pain in the butt. I think all that's going to do is confuse us and take a lot of time, so we're going to skip on over that one. Okay, you guys give these two a try on your own if you can. Pause the video now and see what you can do. When you're ready, go ahead and turn it back on. Let's see if you got the same thing as me. Okay, measure of arc ACB. So A to C to B, right there. That is opposite that angle. So all I have to do is take 2 times 120. Notice that the vertex is out there. Okay, it's like an inscribed angle. So 2 times 120 gives me 240 degrees. Okay, this next one, we gotta find X there. So, in order to find X, what do we have to do? Okay, so notice that X right here, this one and this one would be going together if we think about them intersecting on the inside of the circle. So what we can do, because you got to be careful, that 52 degrees is right there. It's not this angle. So what we need to do is think that right here, these two angles are supplementary. So I could go 180 minus 52, which tells me then that this angle right here is 128 degrees. Okay, since they're intersecting on the inside, I can say that that angle, 128, is equal to 1/2 times, since it's on the inside, I'm adding, so this would be 144 plus X. Okay, a couple of different ways we could do this. You could either multiply both sides by 2 or distribute your half, however you want to do it. 128. Actually, I'm not going to distribute the half. I don't like doing that. I'm going to multiply both sides by 2, because then this 1/2 and 2 are gone, which is going to give me 256 is equal to 144 plus X. I'm going to subtract 144, and we would get that X is equal to 112 degrees. Okay, not too bad. Got one more here. We're not going to do number 4, so go ahead and scribble that one out. Okay, number 3. What do we got to find there? It looks like Y is what we got to find. Notice that I've got these intersecting on the outside of the circle. Okay, so remember, outside means you got to subtract. So that angle of 26 is equal to 1/2 times Y minus 30. Okay. If I multiply by 2, that would give you, what, 52? So again, multiply by 2, because those are gone. So that gives me 52 is equal to Y minus 30. I'm going to add 30, giving me that Y is equal to 52 plus 30 would be 82 degrees. Okay. Homework. Page 683 to 685. So you got 3 through 14, 16A, 22 through 24.